no biggie. Is everybody okay with that plan? At least for now? Yeah, Katie.
Is it possible, like, I get on the semester's test, so there was like examples of just like problems from our book that.
Yeah, I'll have the Tuesday next week we'll treat as a review day, and we can do some of that stuff. As far as the Thursday stuff though goes, I would concentrate on just working through the FRQs that I gave you. If you feel good about those, I think you'll be fine. But again, there's like, as you're going to see on the AP exam, especially on the FRQs, you get stuff from lots of different places in the chapter into one question. Like you'll get derivative stuff and integral stuff in the same FRQ. You know, so you have to be kind of prepared for that. So, okay. Does everybody feel okay with that plan though? Pretty clear as to like what's happening when? And Katie, I can get you, again, I'll get you guys some question numbers here. Yep. I just haven't had a chance to do that. Been worried about like getting the test written and like the AP questions sorted and answered and all that jazz. Okie doke. All right. I guess we could do this first. Did you guys have questions from the 2 homework pages that we did from last time? Rita? 9.1, number 13. Grab that real quick. Sorry, I have to do this. All right. Here it says match the differential equations with the solution graphs and then give reasons for your answers. So what I would look for first would be this one that's the horizontal line, trying to figure out like, okay, which one of those is just 0 flat all the time? Clearly it can't be number 1, right? Because you have 1 plus, you know, like positive things, so you're never going to be 0 all the time. And this one, 1 over 1 plus, again, a positive, can't be 0 all the time because the fraction has a numerator of 1 in it. So it's down between these two. So let's see here for a moment. What's going to be the best way of telling the difference here? Well, I guess when I look at B, this horizontal line here at 0 has y coordinate of 0 all the time, right? So if y is 0 all the time, that's going to be sine of 0, which is 0, times cos of 0, which is defined, that's 1. So this one looks like my answer for D. Now let's take a look through on the rest of these. So if I'm at 0, 0, oh, this is the solution graph. Oh, poopy. Hold on a second. I have to think about this a different way. My apologies. So let's think about it this way. At 0, 0, the slope should be 1 on this, right? So if x is 0 and y is 0, the slope for my function should be 1. So I'm going to look through here. I mean, it could be this one, it could be this one. It can't be those two, right? So I'm going to just kind of like ignore 1 and 2 for now. As we move to the right, as x gets bigger and y gets bigger, the slope should be getting bigger as well, right? And as x gets smaller and y gets smaller, again, the slope should still be getting bigger, should be getting steeper. So I think 3 is my answer for part A. All right, let's look at number B now. So if x is 0 and y is 0, my function is 0, right? Or my slope is 0. So it could be this one or it could be that one, because this one definitely has a slope that's not 0. So let's, ignore that one. So now let's take a look. So if I continue on, if I have like x is 1 and y is 1, the slope looks like it's positive, right? So let's do that. X is 1 and then y is 1. So I'd have e to the negative 2 times 1. That's a positive number. This one has 0 slope there, so I know that can't be it. So this one should be B then, I suspect. Is this feeling okay? Okay. Going on to C. So I'm down between these two. Again, I'm going to look at what happens at 0, 0. Well, if it's 0, 0, I have a slope of 1/2, right? 1 over 1 plus e to the 0. Well, this has slope 0 at 0, so I know it has to be this one. And then process of elimination makes that D. So again, I'm just kind of like, what is the slope at some points that are easy to figure out, and then look at the graph and go, okay, which one has plausibly that same slope at that same point? Okay, it's, I can eliminate some, and then, okay, let's look at the next, some other point and see which one fits better. That's all I'm really kind of looking at. Is that, yeah, again, it's one of those it's not hard once you've seen it done, but it's like working through on your own, doing it the first time is difficult. I guess I can leave all that stuff there. All right. Shall we start the new stuffs? Yeah, Elena. Yeah, go ahead. All those parts? I'm just teasing. It's fine. All right. What can you say about about a solution of the equation y prime equals negative x squared just by looking at the differential equation? So y prime is the slope, right? If the slope is negative y squared, what can I say about the slope? Well, it's always non-positive, right? Could be 0 or it could be a negative, right? So we would say then that like my function should be like monotonically decreasing. It's either decreasing or staying the same. That would be my answer there. I don't know what the back of the book says, but that would be what I suspect it would say. Does that feel okay? Can't really say much more than that just from looking at the differential equation. All I can do is talk about what the slope of the function should be. And here I know it's always 0 or negative. So it's always like decreasing or staying the same. It says verify that all members of the family, yada, 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 are solutions. Okay. Can you think of a solution of the differential equation that is not a member of this guy? Well, it's saying that, like, can we think of a solution to this that doesn't look like that?
Okay, then I'm good. I just didn't know what part A and C were asking, but I got B and D.
Okay,
Okay, thank you.
sure. Yeah, no, I think that yeah, I'm not entirely sure right off the top of my head what it would be. I mean, that family is the one that I would be. I think you probably get one with a natural log in it. Like if you did a negative natural log, I think that would probably work. Right? Because if it's a negative natural log, it's going to look like that. Right? Which is decreasing all the time. That's my suspicion. I'm just trying to think of familiar looking functions. That, and I know what we're doing today and could use the techniques that we're going to do today to actually just solve it, which is lovely. All right. So today, 9.3, we're going to talk about separable differential equations. Here we're actually going to solve a differential equation algebraically just using calculus. So the idea here, if we have some differential equation like dy dx equals f of x times g of y, what I want to do is I want to get all the y parts on one side of my equation, all the x parts on the other. To do that, I'm going to have to use multiplication and division as my really only tools. So to get the y's on one side, I divide by g of y to both sides, and then multiply both sides by dx. And that'll give me this. Then I can integrate both sides because each side, the integral is with respect to a single variable. I can just proceed by integrating those using the techniques we've developed up into this point for integration. That's the entire idea, all of what we're doing today. You tack on a plus c at the end, and maybe you have to get a y by itself to try to get a closed formula for it, but it's basically algebra at that point. Yeah? You need to do a u substitution. Euler's? That is like an approximation method that I skipped last time.
So we have to do 9.
Oh, is that what that was in the homework? No. My apologies. I skipped that and I forgot to go back and update the homework set. Yeah, Euler's method is an approximation technique to solve a differential equation. It would be a BC topic that I chose to omit just because we're looking like we're going to run short on time to try to get this done before spring break. Maybe we circle back after spring break and take 20 minutes somewhere and kind of talk about what that looks like. But all right. So it says, let's do an example here. So it says solve the differential equation dy dx equals x squared over y squared. So to get the y's on one side, I'm going to multiply by y squared to both sides. And to get the x's on one side, I'm going to multiply by dx to both sides. Cool? Integrate both sides. What's the antiderivative of y squared? Okay. And the antiderivative of x squared? And I'm going to tack a plus c on here. So what you have is fine. If I wanted this all in terms of y, what would I do? If I just wanted this as a y equals, multiply both sides by 3. And now 3 times c is still just c, right? I'm just going to, because it's a constant, right? Like, it's fine.
Okay.
Right? The c just absorbs whatever you do to it, basically. Because 3 times c is still just a constant.
Right.
So just call it c still.
So you just solve for y and then throw the c on at the end.
You could do it that way also, sure. Yep. Technically speaking, like, the c comes immediately after you do the integration. And I'd be concerned about making sure the plus c is under the cube root as opposed to have the cube root and then the plus c. So that's that for part A. Part B says then to find the solution that satisfies the initial condition y of 0 equals 2. So when it says find the solution that satisfies the initial condition, what it's asking you to do is solve for c. So y of 0 equals 2 tells me that I should plug x, or 0 in for x, and 2 in for y. Oops. Everybody's cool? So what's c have to be? Yep. And there's my specific solution that satisfies that initial condition. Is this okay? Fairly straightforward, right? Like, not terrible. In fact, the integrations you'll have to do here typically are going to be much easier than any of the integrations we've done to this point. Let's take a look at this yucky looking guy. What are we going to do here? Yeah. So I'll have like 2y plus cosine y dy equals 6x squared dx. Cool with the separation? Integrate both sides. The integral of 2y is y squared. The integral of cosine is negative sine. The integral of 6y squared is, yeah, I might say 6y squared, 6x squared, Mr. Public.
Yeah.
And yes, good. And then I'll tack the plus c on at the end. Now, am I going to be able to find a closed formula for y here? Will I be able to get one y by itself? No. Why not? Because I have the y inside of the sine also, right? So this is as good as I'm going to be able to do. I'm going to stop right here. This is fine. Feel so far so good? Is this good? We like this?
So far, too easy.
Again, you just finished the hardest things we do in this semester
Really?
with the volumes and stuff.
Really?
I think that this stuff we're doing should be easy.
It's hard. It's easier.
Yeah, I think it's
Yeah,
like,
it's hard.
I think conceptually it's harder to like.
Really?
Yeah, the volume was like, I don't know,
Just like
it's like
six,
something
right?
low, like, even down there.
Look at, before you freak out about 6.4, which I know the textbook problems are hard, look at the free response questions. Look at the multiple choice questions. Look at what the AP is actually going to ask you to do for that kind of thing. It is much easier than the textbook questions. Okay? It'll look much more like 1, 2, and 3, where it's like, here's the function, and just find the total. Okay, so don't like get too bent out of shape about that piece. Okay, what I will ask you will be much similar to the AP stuff than these super physicsy things. Not that physics isn't important; it rules our life, but let's not pretend this is physics class when it's really calc class. All right, so let's say we have the equation y prime equals x squared y.
Just rewrite it.
Yeah, I'm rewriting y prime as dy dx immediately. So I divide both sides by y and multiply both sides by dx. And we integrate both sides. What's the integral of, or the antiderivative of 1 over y?
Natural log.
Close.
Or absolute value.
Thank you. And then the antiderivative for x squared is? Yeah, x cubed over 3. And what do we still need? Plus c. Now, let's say we want to get the y by itself, because that's still possible. What would I need to do to get the y by itself? Yep. So e to the both sides. But I still have that absolute value around the y. How do I get rid of the absolute value? Yes, plus or minus. And now I will tell you that if you're looking at it multiple choice question, they're not going to have it look like this. So if I have plus a constant in my exponent, how can I rewrite this? Right? Because if I have addition inside the exponent, that's multiplication with the same base, right? And guess what e to the c is? Just a constant. So it probably would look like this. What did you think today?
I like this.
I like that.
So if C is ever in something without another variable, we should write it as C.
Mm-hmm. Yeah. Yeah, I mean, if you times c by c, it's still constant.
Right.
You would divide it, still constant. Like, you have to, like, you know, like if you square root of like something plus c, the c doesn't absorb the square root, but it absorbs like multiplication or division, or if you add 5 to c, it just, you can still see, you know, like they can absorb that stuff up. But if you left that as like 3c before, like if you did 3 times c and just kept that all through, still work. It'll still work. All right, so a couple of problems like this to practice. What happens though if your differential equation is not separable? Yeah, so that's a linear differential equation. So let's look at what happens for one of these. Okay, and this is the last topic that I want to do before the test. This is even, and I'll be honest with you, this is even a BC topic. So like you wouldn't even be responsible for this on your AP exam you're going to take. I would ask you to be able to do this on the test. Because I think this is like a cool idea, not that bad. But just as you FYI, for the rest of the semester, I'll sprinkle in a couple of other BC things that I think are cool to see before you take a Calc 2 course or whatever. But we won't have any more tests. Won't have any more like, you know, homework sets probably. Well, I mean, I might assign some stuff just to like as review practice stuff to make sure you do it. But yeah, like the hard parts are, like the stressful parts are done, right? It's just getting ready for the exam at this point. Yes, go ahead.
Could you make, I mean, like, at the time before the actual AP exam, but could you make like one of those pages with like every like theorem that's like important, like in Yeah.
We'll see.
Actually, now that I think about it, it's a lot.
It's a lot to ask. We'll see what we can do, though.
Okay.
The one thing you could do, though, Jacob, is you could just go through the notes. Like, all of the notes are there, and all of the screen caps you can just like cut and paste onto your own.
Okay.
You know, if you wanted to do that, like you could start on that.
Okay.
And if you wanted to share it with me, I'd be happy to post it for everyone to use.
Okay.
You know, or you could put it in the collaboration space where anybody can get it. Even if you wanted to do that, that would be cool.
Okay.
Tessa.
Towards the end, you let us know what all of these and what actually.
Yeah, we'll go through and be real clear. There's not much BC stuff that we've done, but we've done a little. Okay? All right. So one type of non-separable differential equation is called a linear differential equation. Linear differential equations are of the form dy dx plus p of x times y equal to q of x. So p of x and q of x are just functions of x. You know, like p of x could be 1. It could be 7x squared. It could be e to the x. It could be cosine of x squared plus 7. There's just some function with only x's in it. Is everybody okay with that? And again, sometimes I might have to rearrange my equation to get it into this form, but that's okay, right? The key is making sure that that dy dx is by itself. So let's look at an example here. The equation x y prime plus y equal to 2x. If we tried to treat this as a separable differential equation, what's the hiccup here? It's that. Because you're not going to ever be able to get y times dy, which we need to have to integrate. Right? That's the hiccup. That's the thing that's causing this to be unseparable using the techniques we did from last time. Right? So here's the takeaway. X, y, if I take the derivative of that, is xy prime plus y. Right? If I do the derivative of xy, I get xy prime plus y. Again, you can think of y prime as dy dx, right? If that makes more sense. We're differentiating with respect to x. That's my ticket right there, because that allows me to take this side that had the plus in it and just rewrite it as that. And now when I integrate both sides and use some sloppy notation, the integral cancels out the derivative. I'm left with just xy. The antiderivative of 2x is x squared plus c. And then I could just divide both sides by x and I'm done. So the trick is going to be, how do I accomplish this? We'll do some specific examples. I'm kind of racing through this one right now because it's not how we're going to do it. It's just kind of like me building up to the technique we need. So we're just making an observation of like, okay, here was a linear differential equation. I could not do this separately. I noticed that, oh, this left-hand side could have been the result of a product rule derivative. If I can take advantage of that fact, now I've got it to a point where everything is integrable and I can go about my business. The trick is going to be, how do I collapse that left-hand side into a product rule derivative in a way that I can do it for any linear equation? Okay? So let's do this in general. Okay? So let's take that first order differential equation or linear differential equation, dy dx plus p of x times y equals q of x. I'm going to multiply both sides of this equation by some function that I'll denote as I of x. We call this the integrating factor. we'll select that I of x such that I of x times dy dx plus p of x times y is the derivative of I of x times y. We'll talk about how to find that I of x here in a moment, just for the sake of argument right now. Just trust that we can do this. So when I do that, I multiply both sides by I of x. That allows me to translate that into just the product rule derivative. And now I can integrate both sides. The integral cancels out the derivative. And then I divide both sides by I of x. And here is my solution, right? Just kind of outlining the process right now. So let's talk about how we get that I of x, right? So I've multiplied both sides by I of x, and I know this has to equal that product rule derivative, right? So I'm going to distribute through my I of x on the left-hand side and then do the derivative on the right-hand side. I notice that, hey, this guy can cancel out, leaving me with that stuff. And if then I can cancel the y's. And I'm here. And that gives me that p of x is going to be 1 over I of x times the derivative of I of x. If I integrate both sides, I get the integral of p of x dx plus c is the natural log of absolute value I. And I do e to both sides. And I is going to be a constant times e to the integral p of x dx. That's our ticket. So since that constant can really be anything, let's just choose it to be 1. So our integrating factor to find this will always be e to the e to the integral p of x dx. Done. It's a formula to find I of x every time. You don't have to walk through all that BS that we just did because we did it so that we'd have the formula. That's what we're looking for. Okay. So let's do an example now where we actually do this. There's my p of x. This guy's my q of x. So we are a linear differential equation, right? I'm going to start by calculating my I of x. What is the integral of 3x squared dx? X cubed, right? So if I multiply both sides now by I of x, I have e to the x cubed dy dx. We don't need a plus c on the integrating factor because we still have to integrate again, so the plus c will just get absorbed up into the next plus c. So the integrating factor never needs a plus c. Okay. Okay, 3x squared e to the x cubed y equals 6x squared e to the x cubed. But the whole point of this is this left-hand side becomes just the derivative of I of x times y. Everybody's okay? Again, this is just I of x times y. It's always going to be what happens. We're choosing the integrating factor so that we can do that condensing and just say that left-hand side is the derivative of this product. Is that okay? You can just trust that it works. It's like the completing the square thing. Like we add the b over 2a squared or b over 2 squared to both sides, and then it factors to a perfect square. We don't have to think about it. We just do it because we've chosen it to work. We're doing the same thing here. We've chosen I of x so we can do that condensing every time. Don't worry about how it works. Just trust that it does. That was what we spent the time in the beginning doing, was showing that like this will always do this. We've chosen the I of x carefully so that it always does that. Jacob.
What do you think that's second line?
So you're saying going from here to here?
Yeah.
It always does. We chose I of x so that we can do that, right? So that we can say that that left-hand side is just a derivative of the product I of x times y. So that's why we chose I of x the way we did, so that we can do that condensing.
Okay.
So it's just a factor of how we chose I of x, and we're choosing I of x so we can always do it. We don't have to think about how we do it.
Right.
We can just trust that we can because we designed I of x to allow that to happen every time.
So you just after the first sentence, like after you find I of x, you just attach that to all the terms.
I multiplied both sides by I of x. Integrate both sides. So the integral cancels the derivative. How am I going to do the antiderivative of dx there? 6x squared e to the x cubed. Yeah, I would u sub this. What should the u be? X to the third. So du then is and if you want, you can make that multiply both sides by 2. That's probably what I would do. Did you guys see that? It's okay. So when I do, what do I have then? I just have e to the u 2 du, right? So that's going to be 2e to the x cubed, and then plus c. And then to get the y by itself, I'll just divide both sides by e to the x cubed. And probably would choose to write that with a negative exponent, just so it's a little less yucky looking, but it was fine before. It's not wrong. Should we do it again? Yes. So this is the same kind of problem, but notice we've also given an initial value, so we're going to be solving for c at the end as well. right now, is this currently written? Is it in that linear form? Is my differential equation in that linear form? No. What do I need to do to get it into that linear form? Divide both sides by x squared. So that gives me dy dx plus y over x equals 1 over x squared. So what's my p of x then? Not y over x. What? 1 over x.
Oh, right.
Right? Because the y has to be there, right? This y is that y. So like p of x is the 1 over x. So my integrating factor then is going to be e to the integral 1 over x dx. Why was I able to dump the absolute value? Because the problem tells me that x is greater than 0. Which is super nice because integrating an absolute value, I don't want to mess with those. It's actually usually a technically very tedious and difficult process.
We don't even know how to do that.
Well, we've done the integrals of absolute values before, but it wouldn't be something as complicated as this kind of an integral, right? Where you just have to figure out where it crosses the x-axis and then just do the negative. Like you break your but an indefinite integral with an absolute value in it is like, what do we do with that? Right? Like that doesn't. So a definite integral of an absolute value, sure, but it'll be something that's like not difficult to handle. You just have to remember what to do. This here with an indefinite integral, like I wouldn't even know what to do. I'd have to look it up. All right. So we know that when we multiply both sides by x, the left-hand side becomes the derivative of xy, and the right-hand side would just be 1 over x. Again, I chose my I over x so that when I multiply it to the left-hand side, it'll just be the derivative of I over x times y. Every time. I don't have to even FOIL this stuff or distribute the stuff out. I don't have to show how that happens. I just know that it does. Everybody's okay? Integrate both sides. So the integral cancels the derivative. The integral of 1 over x dx is just natural log absolute value x plus c. But again, since x is greater than 0, what can I do here? Yeah, I can just drop the absolute value. And then to get the y by itself, well, I think I'm going to solve for c right now. Right? So x is 1, y is 2. Feels easier than having the fractions rattling around in there, doesn't it? So c is 2. Natural log of 1 is 0, right? So I can say then y equals the natural log of x plus 2 over x.
So I of x is equal to e to the integral of p of x?
Yes.
Okay.
Every time.
Okay.
Every time we do that way.
And then we can just simplify it to
Derivative of p of x times y.
Okay.
Yes. So again, like, not that difficult of a process. It takes a minute to remember like the formulas that you need to like use here, but the integrals we're doing are not difficult integrals, right? Once we've gotten to the point where we're integrating, it is usually smooth sailing.
If it's the derivative of p of x times y, why is it not y over x?
It's the integral of the, what do you mean? I'm sorry, say it again.
Wait, so when you multiply the I of x to both sides, you just know that it like simplifies to the derivative of p of x times y, right?
Correct.
But isn't p of x 1 over x?
P of x.
Yeah.
Oh, goodness gracious. No, I'm sorry. It's I of x times, right? Where is it? Yeah, I said that wrong. My apologies. Yes, it is. Where do we go? Where do we go? Where do we go? Yeah. I of x times y.
Okay.
Sorry. Yes. Yeah, that's a big oopsie on my part. I of x times y.
Okay.
I did it right. I said it wrong, which I don't know which is worse. Probably doing it wrong is worse, because at least if you look at the notes, it's correct. But goodness gracious, yes, thank you. All right, one more example, and we'll call her a day. What do you think? Is this not bad either? It's we've done much worse than this, right?
Yeah.
We've done much worse than this. All right. So is this in the linear form? Yes. What's my p of x? 2x. Everybody agree? So I can say then we have the derivative of I of x, Mr. Gulick, times y equals 1 times I of x, or just e to the x squared. So far, so good? We'll integrate both sides. The integral cancels the derivative. And now, how am I going to do the integral of e to the x squared dx?
Good question.
Well, it's an indefinite integral, so the calculator would not help you here. Guess what?
We don't. Leave it.
Yeah, we're going to just leave it. Yeah, we're just going to leave it. Because it doesn't, it can't be expressed in terms of like elementary functions. Like, we just can't do that integral. But this is a perfectly reasonable function. So we're just going to leave it that way. And then we'll divide the e to the x squared over. So we'll just call this final answer. This guy, and
Why is there a plus C if we didn't do that?
we did though. Right, as soon as we draw it in, the plus c comes in. Does that feel okay? Now, to remind you, you may run into like an integration by parts problem inside of one of these. So if that looks like something you might have to do, keep that in the back of your mind, that like you can do that here, and that might come up. Remember, this is chapter 9, so they know you've done chapter 7 stuff. So like you could have to do an integration by parts in one of these along the way, just as a heads up. But that's it. That's a wrap.
For the year?
Yeah, I mean, we'll do some review, and we'll
Gather a few ideas.
yeah, sprinkle in a few other topics that I think are pretty cool, that are worth seeing before you're, like if you're going to take a Calc 2 course, you'll probably be glad that, oh yeah, I kind of remember doing that. But you guys going to take this test, and we're going to come back from spring break and just kind of get into reviewing.
I have a random calculus question for you.
Yeah, go ahead.
So like, derivative of e to the x is e to the x.
Yes.
When can you do that, and when does it have to be like a chain rule?
So if you have e to the f of x, that's a chain rule. So if the function is anything other than x,
That's a chain rule.
and even if there's an x there, technically it's a chain rule, but the derivative of x is just 1.
I think we had this discussion like months ago, where like isn't every derivative just a chain rule, except sometimes it's just 1?
Yeah.
Okay.
Yes. That's a perfectly reasonable way of thinking about all of that.
Okay.
Yes. 100%.
So then it would just be obviously the original function e to whatever times, and then whatever the inside.
The derivative of the
Right.
of the exponent there. Yeah. For sure. So yeah, we'll try to get you guys all studied up before the AP exam, so you're not left to do a ton of stuff on your own, other than like, oh yeah, I know I'm not real sharp here, let me do some extra practice here or whatever. But my hope is to have you real prepared, that you walk in and you feel like you can do some stuff.
You need a 58 to get a 5, right?
I think I had this in here somewhere, right?
Yeah, it was on there somewhere. I feel like I remember it saying 58 was a 5.
And now it's just like, my computer's being so slow right now. Where were you? Was that not here?
Probably under the exam day, maybe. Oh, I lied. Oh yeah.
Show all. There it is.
68.
So this was from 2020. This might get adjusted. It might go up or down a point or something. But that's from 2020. 68 out of 108 was a 5 in 2020. Well, this is points, really. Each multiple choice is a 1 point, but the free response could be like, I think each question is like has 7 points to it.
You're not gonna put A for every multiple choice answer. I could get a 3
That's a 60.
if I knew what was going on in the other.
Sure. Yeah. Yeah.
Okay.
Here. I mean, at the end of the day, what this comes down to is if you understand what's going on and you're just very good with your calculator, you can get a 3. Like, you can get a 3 if you understand what to do. Like, I'm garbage with my algebra, but like, I can get it into my calculator. My calculator can get me the answer to come out. Like, I'm real effective there. You can do quite well. But honestly, like, with what I've asked you to do this year on the test, like, nobody's been getting, like, those tests were very difficult. They're very AP centric. And even if you're getting a 50%, what's a 50%? Where does a 50% land? That's a 4. So even when you feel like, oh, I just failed that without the curve, but that's like a 4. Here, and
What's the average like of this class like before curve, do you think?
oh, I don't know, to be honest. I have a file with all that stuff in it somewhere, but and I'm going to tell you this right away. right now, right here, if you try for all 4 parts, like if you honestly try as hard as you can for all 4 parts and you don't quit, there's no one in here that should get less than a 3.
Wait, 4?
There's 4 sections. There's multiple choice with calculator and multiple choice without.
Are those, like, separated?
Yes.
Oh.
Free response with calculator, free response without.
Do all of the MCQs first. And is this like a 4-hour-long exam?
So I'll let me. Oh my goodness, it locked me out. Oh goodness. Computer. So if I go back again, when I had the exam format. So Elena, so section 1 is the multiple choice. It's 1 hour and 45 minutes. You have 1 hour for 30 no calculator multiple choice problems, and 45 minutes for 15 calculator problems.
3 minutes question.
In section 2, you have there's 6 questions. You have 1 hour and 30 minutes. You have 30 minutes to do 2 calculator questions, and you have 60 minutes to do 4 no calculator questions. And what I will tell you, again, if you try as hard as you can for all 4 parts, I don't think there's a person in any of the sections that should get less than a 3. It's totally realistic for every single one of you. Many of you, I think, are certainly 4 or 5 material. Like, could easily do that. But it requires you to try on all the sections and not just give up. So when I see like reports come back and students get 1s, all that tells me is you just gave up. You just gave up and you phoned it in, and you just like, I just left all the things blank, or just drew some pictures and just like twiddled my thumbs for 45 minutes or whatever. So just resist the urge to do this. You're stuck there for the 3 hours and 15 minutes. You are stuck there for the 3 hours and 15 minutes, right? You're never going to get that time back. That is sunk time. You might as well take that time and try as hard as you can, and maybe you make yourself a few $1,000s by scoring well enough to get credit at college. That is thousands of dollars. Even if you don't get course credit, if you get general credits, it is thousands of dollars for credit hours. You know, like, even if they make you take calc again, if you get the 5 and you get the credit hours, that's 4 credit hours. That's like $3,000.
Well, no, I'm putting this in, like, it's impossible to get a 3. Like,
Yeah.
You could just put A for all of them and then try out 2 hours.
I mean, you still have to sit there for 2 hours, though, so you might as well, I feel like that would go faster.
If you just tried.
Yeah.
Just try. Like, it's that simple. Like,
For some weird reason, this AP test seems like it's going to be easier than all the other ones I've taken. In terms of like what you actually need to score to get a good.
yes, yeah, I think it's quite generous.
Yeah, like AP comp, you can only get like 4 wrong and then you're down to a 4, and then 6 wrong and you're down to a 3.
Yeah, this is. There's a lot of room for mistake, because I think they acknowledge that you do something silly and you drop a negative sign. You knew what you're doing. It wasn't a math issue. You just got it wrong.
That's something that they would like not give you any credit for, right?
Well, I mean, I'm meaning like even a multiple choice section.
Oh.
Like you drop a negative sign and the answer with no negative is there. You pick it. You knew what to do. You just made a silly mistake, like a non-calculus mistake.
Right.
So I think the scoring guidelines are built around like taking that kind of thing into account.
Okay.
But even on the free response questions, like if you don't know what to do, but you know, like, okay, I know I have to do like the intermediate value theorem in here somewhere, but I don't know what. At least start. Like be like, okay, so I know that this is continuous, so I can use the intermediate value theorem to go between this and this, and I'm not sure what to do after that. But that's probably points.
Did they make you prove it? Like, oh, like prove that it's continuous to show why you use it?
By prove that it's continuous, it's probably just that stating that because this thing was twice differentiable, like it was given to in the problem.
Okay.
Almost never are they going to make you like verify that something is continuous. But even if they did, you'd be like, oh, because it's a, like a sine function, and all sine functions are continuous.
Right.
Or it's a polynomial plus a sine function, and all polynomials are continuous, and all sine functions are continuous. Like I would just use that as an explanation if you ever had to. I don't think you would. On a free response, I think they would just be like, so we have this function that's twice differentiable and this function that's twice differentiable, and like, here's some questions now. And it's probably, anytime you see that in there, expect it's there because you have to use like a mean value theorem or intermediate value theorem, and they're giving you the conditions in the problem that you need, but you need to say it in your answer. You need to acknowledge that like, oh, because this is blah, 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 I can do this theorem which states blah, 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 blah.
It's weird. Sometimes like the points are easier to get than you think.
Yeah.
Like I was watching an analysis video on those like FR3s that you posted on.
Okay.
And the lady was going through like all the point breakdowns and where you earn the points for that problem. And like you get like +2 just for setting up the problem. So it's like it can be easy to get the points on it too.